Hey, good morning, everybody. This is Mr. Aynesworth here at Great Oak High School 2024, and we're going to get into how to calculate z-scores and how to use the z-table to calculate certain percentages or probabilities. And so notice that I have my z-table on the right. I'm going to show you how to use this mystical, magical thing here. And believe it or not, it's not as complicated as it looks, even though it looks pretty damn complicated. Kind of like the unit circle, right? If you've ever been through Algebra 2 or pre-calc. But it's really not that bad. And so what we're going to do is we're gonna go through some basics here, and then I'll put it in context in our next lesson here. So this is just the basic skills, and then I'll put it in a real context situation with real data, and we'll make sense of it. Before we do, you need to go to Canvas and get your documents here. So go into your Canvas, find Prep 3, 1-4 Prep number 3, calculating z-scores and z-table. Upload both of these two little documents here, your student copy and the z-table, into your OneNote, and then of course you can get started. So let's do it. Okay. And okay, so let's read the problem here. So suppose we have a normal distribution of data. Okay. So that's important here. We talked about the empirical rule. This is the previous prep. Okay, this is 1-4. This is prep 2. I talked about the previously here. So if you haven't gone through the empirical rule, you should pause the video, go back and do that first, and then you'll understand what's going on. We talked about that previously. We're going to use that today a little bit here. We'll back our percentages up by this. Okay. But I'm going to show you how to use the z-tables and actually calculate a more theoretically precise percentage or probability using the z-table and z-scores. Okay, so we have this normal distribution of data. Okay, cool. All right. Don't know what the data is, but it's not important. We're doing a skill-based lesson here. And where the population mean is 62. So I'm going to record that down here. The mean is 62, and the standard deviation sigma is 6. So I always write down my info here and the problem, and then I go for it. Okay, we're going to solve three distinct problems here. We're going to find the following probabilities or percentages, okay, using z-scores, okay, not the empirical rule. Although we will back up our numbers here and make sense of it using what we already know about the empirical rule. So that's a good thing. Okay, because the empirical rule is an approximator, and it's a way to get your answers, within a pretty decent approximation, right? But I'm going to give you the method how to get a more precise theoretical percentage. Okay, so here we go. First one, we're going to find the percentage of scores at less than 50, and the way we write that is I'm going to go here. The way we write that mathematically is we're going to use P for percentage or probability that the score is less than, Q is less than 50. So that's how you write it mathematically. The question is, how do you do that? What's the percentage of the data, okay, out of all the data, whatever the data set is? I don't know if we're dealing with a data set of 600, let's say, heights or test scores. I really don't know. But I do know that we're trying to find the percentage of those test scores that scored less than 50. So how do you do that? Actually kind of simple here. So what we're going to do is we're going to sketch it. So we're going to draw a normal distribution, or what's called a bell curve. So sketch with me over here. I'm going to sketch first. And this is going to test your little drawing skills. So draw a symmetrical bell curve the best you can, and then we can get started. Okay? It's not perfect, but that's close enough. Right now, we're going to put the mean right here. The mean U is 62. It goes right down in the middle here. Okay, the symmetrical bell curve uh, is symmetrical about the mean. So you always put that in there. And then we're trying to find the percentage of all the scores that are less than 50. So we have standard deviation of 6. So let's go a couple standard deviations to the left. And let's kind of just get an approximation here first. So let's go one standard deviation to the left. Let me see, 62 minus 6. We're going to subtract 6 here, the standard deviation. That's not an R, that's a sigma. Okay, so we're going to subtract 6 to the left. We add 6 to the right if we had a score greater than 62. We'll do that next. All right, right now 50 is obviously less than 62. So how many standard deviations to the left is that? Well, 62 minus 6 is, I think that's 56. So if you go 2 standard deviations to the left, that's 50. That corresponds to a z-value of -2. So our z-score should be -2 when we calculate it. So that's what I'm expecting. All right. 50 is 2 standard deviations to the left. I'm going to write that down. So 50 is 2 standard deviations, right, to the left. See, I'm using the skills from previous lesson. We talked about the empirical rule here, and when you go to the left, that 1 standard deviation that corresponds to z equals -1. Go 2 deviations to the left, that corresponds to z equals -2. And if you go 3 deviations to the left, that corresponds to z equals -3. If you're on the right, that corresponds to z equals 1. 2 standard deviations would be 2 to the right, z equals 2. And if you go 3 deviations to the right, that corresponds to a z score of 3. All right, in respect to the mean. Remember, the mean is right in the middle of the bell curve. And that's called mu in general, the population mean. Okay, so what we're trying to find now is the percentage of those scores that are less than 50. So really, let's grab a highlighter here. What we need to find is this area here. All of these, the percentage of scores less than 50, which is 2 standard deviations to the left of the mean, which means we got to figure out this little percentage right in through here. So if we just estimate it using the empirical rule, and if we add these two figures here, 2.35 plus 2.5, or excuse me, 0.15, we're going to get about 2.5%. So this is approximately 2.5%, right, using the empirical. Okay, so I'm just kicking in the technique, okay, that we used from yesterday. This is an approximation, so notice I use approximate equal to. What is the exact theoretical figure? Okay, and it's going to be close to 2.5% or 2.5%. But what is the exact theoretical figure using these z tables over here, these z scores and z tables? These figures in here, these are just percentages. Percentages. Okay, you can also call them probabilities. I know they're decimals, but you know if you convert each decimal to percentage, okay, you obviously get a percentage. So I'll get to that in a minute. So right now, what we know is that we know the approximate answer is 2.5. But what's the exact theoretical? So let's go through it here. First thing we do is we calculate a z-score. Okay, now let's put this in red. This comes from your prep. When you read the book, you guys, you found out that every z-score is found by taking the score minus the mean and divided by the standard deviation. Okay, so notice that I wrote x minus mu divided by sigma. This is the score, right, minus the mean divided by the standard deviation. Okay, so to calculate a z-score, which may be an integer, maybe a decimal here, is what we do. So we're going to take our score, which happens to be 50 in this case. So we're going to take 50 minus the 62 divided by 6. That gives you -12 divided by 6, or -2, which makes sense, okay, because I knew it was -2 in the very beginning. All right, because why? I sketched it. Okay, and so it's always helpful to have a sketch here, and we think it's close to 2.5%. Okay, so what's the exact theoretical? So now we have to learn how to use the z-table. So here's a new part. I'm going to sketch the z-table. The z here. So no, let's go over the z-table and just talk about it for a second before we actually calculate it. So notice that our z-score is in the first column, and it's also in the first row. And these percentages here in the middle of the table here, they represent the percentage of the time that something occurs, okay, given some z-score. And it says up here that it's the cumulative area from the left, okay, to the left of a certain value. That's really, really important, so circle that word. So these are the percentages of something that occurs when it's less than or equal to something, okay, or strictly less than something. So let's get this z-score here. So we have a z-score of -2, and -2, z equals -2, it can be written as -2.00. You take your first 2 digits of your z-score and put it on the first column, okay, on the column. And then you take your hundredths place, which has to be 0 hundredths, and you put it up top, going towards 0. Okay, so that goes up here, and then you look at cross and you look down, and then you read your probability. Okay, so we need to find -2.00 on the table and get the probability. So let's go do that. Let's find your -2. So again, we're trying to find z equals -2.00. So we have to find -2.0. Then up here, here's 0.00. You go across and down, and then you read it. And it says right up here, 0.0228, which is 2.28%. That's your exact theoretical value. Okay, these are the exact theoretical values, and the empirical rule that just gives you an approximation. But here's your exact theoretical. So 0.0228. Let's bring it in. 0.0228. What is that equal to? 2.28%. Oops. Let me write that correctly. There we go. All right. To get from a decimal to percent, just multiply by 100. Shift that decimal place 2 places to the right, and you get your percentage. That, my friends, is this right here. So 2.28%. And again, that's close. If you look right here, these right here, these are very close. And they should be very close. All right. Your approximation using the empirical rule, like we did in the very beginning, should be very close to the theoretical. Okay. And so that's how we know our answers are like appropriate. They they uh, they make sense. Is what I'm saying. Okay. All right. Now there's three different cases here that we want to analyze. We just found the percentage of scores less than 50. Secondly, we want to find the percentage of scores at least 70. And then third, we're going to find the percentage of scores between 54 and 72. Okie dokie. And we're going to do the same thing, okay, but it's slightly different. So the first thing we do is we interpret it mathematically. So if you're trying to find the percentage of scores at least 70, so the way you write it is P for percentage. Right? You want to find the scores that are least greater than equal to 70. Okay, what is that equal to? Well, we gotta graph it first. Okay, so let's draw a little uh, normal distribution. Okay, draw a symmetrical bell curve best you can. Doesn't have to be perfect because it's the idea that matters. Put the mean right snap right there in the middle. It always divides the bell curve into two equal parts. Right, left half and right half are symmetrical. All right, and we're trying to find the percentage of scores that's greater than or equal to 70. So let's use the standard deviation. So remember that mean is 62. Standard deviation is not 76. Sorry. Ooh, got a little carried away. Sorry, guys. 6. Okay, problem hasn't changed. Okay, so getting a little crazy here. So let's add 6 to this. Let's go one standard deviation to the right. Okay, again, we're going to the right, so we're going to add the standard deviation. That's 68. And then go to another standard deviation. So add 6 again, so 68. And guess what 70 is? 70 is bigger. Wait a minute. Oh, I didn't add right. Sorry guys. We're getting a little crazy here. Let me add correctly. Okay, 62 plus 6 is 68, right? Plus this is 70. Oh, it looks like 74. So if you plot 70, it's probably going to be right around in here. Okay, there's 70 right there. All right, so we're trying to find this percentage right through here. The percentage of the population that's greater than or equal to 70, which lies to the right. Okay, to the right, not to the left. What is that? Okay, so notice that we're over a standard deviation away. So at 68, that's a standard deviation of 1. At 74, that's a standard deviation of 2, or the second deviation here. So whatever the z-score is, it's got to be between 1 and 2. Okay, it's got to be 1 point something. So let's calculate it. So right now, the empirical rule, I mean, wouldn't give us a really accurate number here, so we really need more precise measures, which is why we teach this. Okay, so we have z is equal to the score, okay, the score minus the mean divided by the deviation. So we have to take the score, which is 70, remember our score is 70, minus our mean divided by the deviation of 6. So what do we get? We get 8 divided by 6. All right, and then you pull in your famous calculator here. You can use whatever you want. I'm going to pull in decimals because that's what we use in class. Okay, though, and we take 8 divided by 6, and notice we have an infinite decimal. And when it comes to decimals here, we always have to round to the nearest thousands. So here we're going to round down because 3 is less than 5. And so our z-score is approximately 1.33. Always round, right, to the nearest hundred. Always nearest hundred. Very important there. Highlight that. Okay, importante. Okay, z is equal to 1.33. Now to check this out on the table here, so let's draw the z table. So z, we take the first two digits, put it on the column, take your hundreds digits, which is 300, so 0.03, and then we go across and down. So across and down and read that number. Okay, so let's find 1.33 on the table. Now there's two sides to the table. There's the negative side and then the positive side. So we got to go to the positive side and find 1.33. C equals 1.33. So 1.3 is here. 0.03 is here. You go across and down and read your value. Okay, and it's obviously 0.9082. But remember, it's always the area from the left, all right, to the left of a number. So this is the percentage to the left of the number, 0.9082. Okay, 0.9082, which is 90.82%. Remember, just multiply it by 100 and shift that decimal. Okay, pretty easy to do. So what we just found was not the answer. We found the area to the left, this area in blue. Okay, so 90.82% represents the percentage of people to the left. We want to find the percentage of people from the right. Okay, so to do that, what we're going to do is we're going to just subtract it from 100% because there's 100% of the data underneath the bell curve. So this area here is 100% minus the 90.82%, which is 9.18%. Okay, so we just found it here. So we put this in red. So the percentage of the figures, or the population that's greater than 70 is equal to 100% minus 90.82%, which is 9.18%. Just do the arithmetic and decimals and you'll see what I'm talking about. And that's case number 2. Right? So the first one's the easiest one because you don't have to subtract the answer from anything because we're trying to find the percentage of the population that's less than 50. Second case, we're trying to find the percent of the population that's at least 70, so we have to figure out the percentage to the right of the number, which means we use the table and we get a percentage, and we subtract it from 100, and we get our actual answer. So there's a little bit more work to do, right? One extra step, subtract it from 100. The third case is the trickiest and involves the most, so let's go through that in detail. Okay, so on this one here, we're trying to find the percentage of scores between two guys, 54 and 72. So here, the way you write that mathematically is percentage of scores that are between 54 and 72. And if you're between 54 and 72, x has to be between these two. So we use a compound inequality there. All right, so how do you do that? Well, let's get a strategy going. So the first thing you do is you draw the situation so you can understand it. So you draw the bell curve like we always do. Always draw the bell curve first. Draw a symmetrical bell curve so you can come up with a plan. All right, put the mean in the middle. Okay, so remember the mean. In this case, it's 62. All right, the standard deviation is 6. So put the mean in the middle. Divide it into 2 equal halves. All right, and then plot 54 and 72 and just approximate. So 54 is over here somewhere. Okay, so 50, 54. I'm doing a really rough sketch. And so we're going to find the probability that we can find the probability here that a score is less than 54. We do that in case number 1. That's this. Okay. Then we're going to find the probability or the percentage that the score is less than 72, which is obviously to the right. So it's here somewhere. Okay, I'm just sketching right here. So let me highlight this one. So I'm going to do this right here. So I'm going to find that probability. So left of 72, that's finding the percentage of the population that's less than 72. We can do that. We can find both of these. But what we want eventually is we need to figure out a way to get the percentage that population that's between these two figures, okay, between 54 and 72. So what we're going to do is we're going to just use a geometry skill that we learned. Okay, we're going to take the big area, which is in blue. Okay, so the big area. Let me just sketch this here. Okay, I'm going to subtract the little green area, right, from 54, which is very small. All right, to do that. So the big one, right, is the percentage of the population that's less than 72. Oops, come on, I write the right numbers here. There you go. And we're going to subtract the little area, right, which is the percentage of the population that's less than 54. So what we need to do is calculate two z-scores and two percentages and simply subtract them, right? And then we get the percentage in the middle, right? So big minus small. Okay, so all right, so we need some z-scores. So let's start calculating here. Uh, okay, and then here we go. So first z-score. So we're going to take 72 minus the mean and divide that by 6. Okay, that's 10 divided by 6. Okay, so 10 divided by 6, bring in the decimals here. 10 divided by 6. Sorry, just give me a second here. Give me a second. Guys, I'm sorry about the pause. Yeah, I have an issue right now. Okay, so we have 10 divided by 6 is 1.666. We have to round that. So you round up. So it's approximately equal to 1.67. Okay. Now we have a z-score for that, or we have a probability for that. So the first one here, 1.67. So let's get a percentage for that. It's going to be big because the blue area here is very, very big. So let's find 1.67 on the positive side, obviously. So here we go. Let's find it. So here's 1.6. Here's 0.07. Go across, go down, and you read it. 0.9525. Okay. So 1.6 here, 0.07 here. Go across, down, and you have point. What's that again? Forgot it. 0.9525. Okay, so 0.9525. So that's 95.25%. Okay, next one. So that's that big area here. So 95.25%, the big area. Everything in blue. Okay, guys. And then the one in green. Okay, we have to find a new z-score here. So z is equal to the score, so 54 minus the mean divided by the standard deviation. And so here you get negative 8 divided by 6. All right, and then so oops, let's bring back Desmos. Oh, we already know what that is. So it's negative 1.333. So negative 1.33. And then if you do that on the table here, you go negative 1.3 on the vertical, 0.03 on the horizontal, and you can read it, cross it down again. Everything's a crossing down. So let's grab our Z table here on the negative side, find negative 1.33. Okay, so here, here, go across, down. So you have 0.0918. Okay, we're rocking here. So 0.0918. That's 9.18%. Okay, and that's this little one here. So let me label that. So this is 9.18%. That's that little area in green. Okay, in through here. Okay, and then to get to yellow, we just subtract these two. So we're going to take the big area in blue and subtract the green area in green, and then we got it. Okay, so let's finalize it here. So we have the percentage of the population that's less than 72. Let's put this in red here, so which is 90 point, no, excuse me, 95. So 95.25% minus the small one, 9.18%. So let's bring in the calculator again. That's why Desmos is so cool. You just have it right there anytime you need it. So 95.25, right, minus 9.18. You get 86.02. Oh, I gotta put in the right numbers here. Uh, this one, there we go, 86.07. There we go. So 86.07%. All right. And that is how you find the percentage of the data that lies between two different numbers. Okay, you have to find two different percentages, the big one and the small one, for both the values. Subtract them, and you got it. Okay. All right, and then in class we'll do this one here. I'm going to stop the video here because we'll usually have you guys do this in class, and so just show up and you'll be able to do that one. So those are all the skills, the three basic skills of how you find percentages uh, of a of a normal distribution here, and using what's called the z-table in your z-scores. Right? So hopefully that helped you out. If you need some more help, obviously see me in the morning before school, or after school, or at lunch, and I'll help you out. Make sure you be present. So if you guys are seniors, be present, be in class, and you'll learn a lot. So this is Aynesworth here, and from Great Oaks High School, all right, here in financial algebra in the year 2024. All right, you guys take care. See you in class.